Dear students, in this video, we are going to see RSA decryption. Last week video, already we have completed encryption. Okay, we have completed encryption, which means how to find the ciphertext from the given plain text by using the public key. Okay, E and N. That is what we have completed the last week in the encryption. Okay. Now, here we are going to see RSA decryption. Here, suppose ciphertext is given, the encrypted message is given, then how to find the real plain text? And that is RSA decryption. Okay. Now you see, what is RSA decryption? See, these are yes, A or three mathematician names. Okay, they formed the encryption technique. Okay, now this week what we are going to see, suppose if we have done already the encryption, then how to find the decryption by using the private key. That is what we are going to see this week. Okay, now private key is nothing but D and N. What is N? N is nothing but the multiplication of P and Q. Here P and Q are primes. Okay. Actually, this is a condition. Okay. D, E, congruent 1 modulo P minus 1, Q minus 1. Okay. This is the condition. Now, here we are going to find the real message. Real message. That is the real plain text. We are going to find from the encrypted message through the private key. Okay. Now, this is the rule for that. Here also I written. This is the rule for that. Okay. Now, you see, suppose this is the plain text, real message. Okay. What we have done in the encryption, by using the public key, we have encrypted the real plain text message into the ciphertext. That is what we have completed last week. So now what we are going to do by using RSA decryption, now what we have converted in encryption, the ciphertext we are going to take, we are going to convert this text into the real plain text. Okay, that is called decryption. Okay, how? By using the private key, we are going to do this week. Okay, we are going to do this week. We are going to take the ciphertext, we are going to apply the decryption algorithm, and definitely we will find the real plain text by using the private key. Okay, here see, this is the private key D, N. This is the rule for that. We are going to apply the modular exponentiation to find that real plain text by the RSA decryption. Okay. Now, we know that already this. Okay, what are the numeric values of the alphabet A to Z? Okay. Now, we will see this example. Find RSA decryption of the message 09810461. Okay, this is the encrypted message actually. Okay, now we are going to decrypt. Okay, with P43, Q59 and D937. This is all given in the question. Okay. So now, what is the rule for the decryption? Okay, we know that the rule for decryption is this. That is, real text message is equal to ciphertext to the power D. What is given in the question? Modulo N. Okay, N is nothing but multiplication of P and Q, 43 and 59. Okay, given ciphertext is what? That is here 09810461. Okay, what is given P? What are the values given for P and Q? 43 and 59. Okay, how to find N? It's very simple. Multiply this P and Q, that is N. So N is 2537. Okay, what is given for D? That is 937. Okay, so now what is the rule for decryption? You see, this is the rule. Okay, that's what I written in the example also. Now you see here, I'm taking from the given message, I'm taking only 4 digits. See, I divide the given numerical value message into 2 blocks. Already I told you in the last week video. See, if you take all the digits, it's very difficult to calculate the values. Okay, it is very difficult to apply the modular exponentiation algorithm. Okay, so that what I do, I divide into blocks of 4 numerical values. Okay, so I take the first block. You see, first I decrypt the block 1, that is 0981. Okay, so now what is the rule for that? M is equal to C. This is the ciphertext, which means this is the encrypted message is given. Okay, this is the converted message is given. What is given here? I take. Okay, so the block 1 is 981, that is 0981 to the power D. What is D? D is nothing but 937. Okay, I put here. And modulo N. N is 2537. Okay, I put here. So that this real text message is the answer of this expression. Okay, so now to find this value, what we are going to apply, what we have seen in last week, we have seen modular exponentiation algorithm. Okay, so what is that modular exponentiation algorithm? Nothing but is, if I have any expression in the form of b to the power n modulo m, then I can apply this modular exponentiation algorithm to find the value of this. Okay, so now you see here, this is the required one. This expression is nothing but equal to this form. Okay, now if you compare, you can write the values of b, n, m. Okay, see, now we are going to apply the modular exponentiation algorithm method. So now what is the value of b? That is 981. What is the value of n? That is 937. What is the value of m? 2537. Okay, so now what we do in modular exponentiation, first you have to find the binary value of the degree. Here, what is the degree? This is n is 937 is the degree. Okay, this value. So now first we have to find the binary value of 937. Okay, that is nothing but 11101010001. Okay, so now how we give the names of these each digit? See, from right to left, I write A0, A1, A2, A3 until A9, because here we have 10 decimals, means 10 numbers. Okay, in the binary I have 10 numbers. Okay, so I write from A0 to A9, from right to left. Okay, to apply this modular exponentiation, first what we do, we assume the value of x. Okay, first we assume x is 1. Okay, this is given in the algorithm which we have seen last week. Okay, now how to find x, means how to find power, sorry. So now power is nothing but b modulo m. Okay, what is b here? 981. Modulo m is how much? 2537. So apply this, so that answer is 981, because this is small, this is b. Okay, so the remainder is this. So 981. So now power is how much? 981. Okay, so now first we have to assume x is 1, and then we have to find the initial power. Okay, now we can start the algorithm. Okay, we have to start from A0. Okay, this here I have not written the steps. Okay, here actually we have to write 10 steps. Okay, now see, like this problem I have explained in week 4, means in the last week. Now like this you have to write A0 how much, A1 how much, A2 how much until A9. You have to find all this value. Actually this is not the answer, but like this you have to write all the values. Okay, step by step. Okay, here in this question. Okay, here, that's why I put question marks 10 times. Okay, so now first, what is A0? A0 is equal to 1. If A0 is equal to 1, what you have to do? You have to find the new x. You have to go and follow the algorithm. what is in the algorithm? You see here. Okay, now you see, if this value is 1, then you have to find new x. Okay, so now here you have to find new x. Okay, for a naught is equal to 1, you have to find new x. What is new x? That is nothing but the previous x multiply power then modulo m. Okay, but every time you have to find the power. Okay, so now here you have to, for a naught, what's happening? You have to do for a1, what's happening? Means what is x? What is power? For a2, for a3 until a9 you have to do. Okay, 10 steps here. That you have to do. See here, 10 question marks. Okay. Finally, what you are getting for x, you see here, when you apply this modular exponentiation method, finally where you stop, what you get for x. See here, finally no need to find the power, you stop with x in the last step. Okay, what you are getting for x, that is your final answer. That answer is here 0704, means 704 will come, but I put 0. Okay, finally to convert into the alphabet. Okay, so now this is the final answer. Okay, after finding, see, for a naught what is x, what is power, for a1 what is x, what is power. Similarly until n you have to do the iteration, means you have to do the algorithm in the for loop. Then finally for a9 you have to find x, that is your answer, this answer. Okay, this is for block 1, first block. Okay, for this one. Now what is in the second block? 0461. So now similarly you have to do for second block. Okay, what is the numerical value? 0461. Then apply this rule, same rule. What is here in the decryption? Same rule. Okay, this rule, this rule. Okay, so now apply the same rule here. So we have to find what is the answer for this expression. Okay, how? By using the modular exponentiation again. So now you compare with the modular exponentiation algorithm format. So now what is b, what is n, what is m, I can write. Now here, what is the degree? What is the degree here? Same, 937. So you have to find the binary of that number. Then again you will get the same. Okay, a0 to a9, 10 numbers here. In binary you have 10 numbers, zeros and ones. Okay, you have to start from right hand side to left hand side. Then to apply the modular exponentiation algorithm, what you have to do? You have to assume what is x. Then you have to find the power. So what is the rule for power? B modulo m. So what is b here? That is a change. So 461 modulo this m. Okay, 2537. So this is small number. So when you apply this modulo, you will get 461. Okay, that is your power. So what you do here? What you do here? What you do here? Again, you have to apply the steps. How many steps? 10 steps you have to apply. Not 9. You have to apply 10 steps. Okay, apply 10 steps. Means from a0 to a9 you have to apply. Then you will find the x value in the last step. Okay, as I explained here. You see, finally you will find some x value. Actually, this is not the answer. This is the example which we have discussed last week. Okay, so now you will find some x in the last step. That is your final answer. That is m is equal to 461 power 937 modulo 2537 is nothing but this answer will come. Okay, but you have to combine both the answer. See, in the first block, when I decrypt the first block, I found 0704. When I decrypt the second block, I found 1115. So now I have to apply this. Okay, so now h, then for this I'll get e, then 11 is L, then 15 is P. So what is our real decrypted message? That is 07041115, real decrypted message. Okay, but we have to convert into the real text message. So that is the translation back to English. That is nothing but HELE. This is your real plain text. Okay, so this is the method how to decrypt, okay, given numeric value into the English letters. Okay, that's it. We will see the continuation of this in the next video. Thank you.